Hello everyone, my name is Li Chenghao. In this video, I will introduce our paper, Few Short Font Style Transfer Between Different Languages. In this work, we focus on the font style transfer between different languages. Given an English trademark or a title of a movie poster, our goal is to automatically extract the style information and apply to another language. However, the characters of different languages may be dramatically dissimilar. For example, some components of Chinese characters are complicated and do not appear in English letters. Furthermore, the style of font is very abstract and can have many fonts of expression. For example, the fonts on the left side are characterized by thickness and strokes. The font in the middle has some local decorations, and the font on the right side has some global effects. To address these problems, we propose a novel model font translator game. Each time we randomly select K style images and one content image from a standard font. The generator will extract the style information and apply it to the content image. Then, two discriminators check the matching degree of the style and content perspective. The objective function consists of three terms: L1 loss, which is the pixel-wise error compared with the ground truth image. L style and L content are two adversarial losses. The generator G consists of a style encoder, a content encoder, and a decoder. Two encoders extract the style and content representation respectively. Then the decoder will take the extracted information and generates the target image. We specifically designed a style encoder by using three parallel context-aware attention networks and a layer attention network to capture both local and global style features. These three context-aware attention networks have the same structure except the size of receptive field. Context-aware attention networks takes a feature map that's given by the last convolutional layer as the input. Each pixel in the feature map represents a specific region of the original image. Only a small area can be seen in the shallow layer, while a relatively large area can be seen in the deep layer. The task of content-aware attention network is to do a weighted sum of feature maps to a feature vector. The weighted map is given by a self-attention block and a random initialized context vector. They can be jointly trained with the entire system. Note that we have three parallel context-aware networks, so in the end, we will get three feature vectors. The task of layer attention block is to do a weighted sum of three feature vectors. If feature vector 1 gets a large weight, we can think that the model is currently paying more attention to low-level features. On the contrary, if feature vector 3 gets a large weight, we think that the model is currently paying more attention to high-level features. But given a style image, should the machine focus on the local or global feature? We believe this depends on the image itself. So we input the feature map that's given by the last convolutional layer to a neural network, and it generates three weights for us. Then we just summarize them based on these weights. To verify the generative ability of the proposed model, we construct a dataset which consists of 847 fonts, each with 25 English letters and more than 1,000 Chinese characters. We divide ground truth images into three parts. S1 is used for training, S2 and S3 are used for testing unknown content and unknown style respectively. Here are some visual results. The observed style images are illustrated in the first rows, and the ground truth images are in the fifth row. We compared our model with EMD and DFS. Experimental results show that our model outperformed the state-of-the-art models on both pixel and perceptual level evaluation metrics. Our final goal is to generate images that satisfy users, so we randomly select 39 sets of images from the output of both methods and ask the users their preferred images. Table 2 shows most participants prefer images generated by our model. This is an ablation study on the proposed multi-language dataset. We gradually remove layer attention and context-aware attention networks and see the results. For further analysis of the proposed model, we visualize the weights given by the layer attention network. It is observed that when processing handwritten fonts, our model tends to observe local features, while when processing printing fonts or artistic fonts, our model tends to focus on a global feature. Thank you for your attention.